Hello everyone. From today in this channel I will teach all the concepts of class 11 and every day I will update you with a new video, and this chapter will divided into few subparts, then part 1 part 2 like this. All the chapters of class 11 will be completed in this in a series of video. So from today we will start class 11 the concepts, that is motion chapter. Third chapter will start, then we will go for the fourth chapter. After that we will discuss about unit and dimension. So third chapter, that is your about the motion chapter. So students, if you just means after class 10 you have just taken the admissions in class 11, so you have to, when you have taken science, you have to learn the few basic concepts very thoroughly, so that it will be helpful for the advanced physics or in the class 12 physics. Basically in your this motion chapter and your motion in a plane chapter, motion in a straight line, motion in a plane, and laws of motion, in this three chapter most of the foundations of physics are there. So you have to learn these three chapters basically very thoroughly, so that your fundamental will be strong and you will able to understand physics in next year. The chapters like electricity, magnetism and light, all this chapter will be easier for you once your fundamentals are strong. So without wasting the time, we will start the third chapter, that is your motion in a straight line. So chapter 3, that is your motion in a straight line. So in this chapter basically we will discuss about that an object which is moving in a straight line. You know, an object can move in a straight line, in a plane, or in a space. So when the object will move in a straight line or in a single line, then we say the object moving in a straight line. If the object is moving on a plane like floor or on a table or on the ground, then it's a plane. So when the object is moving on a plane, then we say it's a two-dimensional motion. Now when the object will be on the space, then we say it's a three-dimensional motion. So basically in this chapter we will restrict ourselves in the one-dimensional motion. That means object will be moving in a straight line, that is you can say on a coordinate plane if you say only on x-axis. Most of the terms you have learnt in your class 9th. So in class 9th you have learnt about many concepts like distance, displacement, velocity, acceleration, average velocity, uniform velocity. So all these concepts you know from your class 9th. In this chapter in class 11 also these concepts are there, but these concepts also will include along with that some differentiation, integration like concepts, where you will able to calculate the instantaneous velocity, the instantaneous acceleration. So some new concept which are not there in class 9 you will learn here in class 11. But before that I will revise you what you have learnt in your class 9th. So in your class 9th you already know the terms like distance, displacement, speed, velocity. So these terms already you know from your class 9th. Now just I will revise you, or just I will try to explain you what are these concepts, so that you can remember or remind whatever you have learned. So distance basically is a path covered by any path covered by an object. It can be, suppose the object starts from A, it can take any path to reach B. So this path, any path taken by the object is your distance. Now if the object will move in a straight line and for a particular direction, let's say A to B, then this is called your displacement, and it should be the shortest one. Of course, if any object, if it will move on a straight line, then it will be the shortest one, right? So A to B, if it is moving on a particular direction on a straight line, then we say it's a displacement. But at the same time, if the object is covering or with taking any path to reach the same position, then this path is distance. Now you can think of distance is bigger or displacement is bigger. Distance will be, most of the cases, distance will be bigger than displacement, because distance is taken by any path, right? And displacement has a direction. So the thing you may not know in class 11, that any quantity, any physical quantity which has both magnitude and direction, that is called vector quantity. So distance is not a vector quantity because direction is not involved with distance, but displacement is a vector quantity because here along with the magnitude there is direction involved with it. So displacement is a vector quantity. These terms may be new to you. Vector and scalar. Distance is a scalar. I will discuss these terms one by one in detail. What a vector is, what a scalar is. For now, just you understand that a vector is a quantity which has both magnitude and direction plus direction that is vector quantity, and distance is a scalar quantity, that means it has only magnitude. Now speed, will come to speed. So speed will be related with distance and velocity will be related with your displacement. What is speed? The speed means, suppose you are on a motorbike, you are on a car, then you can see there is a speedometer on your bike or car. You might have seen, right? So when you have seen, and you might have noticed that this speedometer needle is constantly changing. When your father or your brother accelerates, okay, then when the means you can realize that you can realize that the speed of the vehicle is increasing. So what does that speed mean? Speed means in a less, if the speed is more, in a less time you can cover more distance. That means the rate of change of distance, how fast the distance is covered, how fast the distance is changing, that is your speed. That means distance upon time is defined as speed. Distance upon time is defined as speed. Similarly, one more term that we are supposed to define, that is velocity. So what is velocity? Velocity, as I told, velocity is a vector quantity, so it will be related with your displacement. It is similar, but it is a shortest one. It is related to your displacement. So velocity will be displacement upon time. That is your velocity. Now all these terms you know from your class 9. Only the new term, what we have learned? The new term we have learned here, the vector and scalar. And briefly I have given an idea that a vector quantity has both magnitude and direction, whereas the scalar quantity has only magnitude. Now let us solve one problem, then you will understand the difference between distance and displacement, and also I will give you some example from speed and velocity. Now for example, this is a square. This is a square of side 2 meter, and the person, suppose one person, he started from he started from here, position A, and reaches position, this is A, B, C, D square. Square means each side equal, so all the sides are equal, right? That means this is 2, this is 2, this is also 2 meter. All the sides are of 2 meter, it's a square. Now the person starts from position A, reaches at position C, right? And if I'll ask you what will be distance and displacement of this journey, of his journey, what is distance and displacement of his journey? Distance is, from the definition itself, it's any path. Distance is any path taken by the object. Now here any path means it has taken A to D, then it moved D to C, right? So this is 2 meter, this is 2 meter, so distance will be 2 plus 2, 4 meter. Yes. Now displacement. What will be displacement? According to our definition of displacement, it should be the shortest one, right, and the straight line. So A to C, if I will join in a straight line, and that will be basically here the diagonal of this square, right? So this will be your displacement. Yes. So displacement will be AC basically here. So what will be the value of AC? You can say the value of AC will be the diagonal. You know the formula, right? What will be the diagonal? Pythagoras theorem you can use, right? Because this is a right angle triangle. Or if you remember that directly also, you can write down the length of AC. Basically it's a right angle triangle, so I will use 2 square plus 2 square root over, that will be your 4 plus 4, so root 8. Okay, or you can say the formula is actually root 2a. 4 into 2, that is 4 root over is so 2 root 2 here, that the formula is root 2a. Formula is root 2a. Root 2 times a is the diagonal for your square, right? Now let us take another example. Let us take one more example of a circle. Okay, this is a circle, let's say radius 2 meter. This is a circle of radius 2 meter. Now the object starts from A and reaches at B, which is exactly opposite to its diameter, right? Now the question is, what is the distance and displacement traveled by the object? Distance and displacement. So what will be displacement? Distance here first. What will be distance here? The distance will be the object starts from A and reaches at B. That means the half of the circumference, isn't it? This is full circumference. Starts from A and reaches at B is the half of the circumference. So half of the circumference means, what is the total circumference of a circle? 2 pi r. So half of the circumference is pi r. R is given as 2 meter. You can calculate easily. 22 upon 7 into 2, that is 44 upon 7 meter. This is the distance covered by the body. Now what will be displacement? Displacement again, the straight line. So straight line is what? Diameter. You can see clearly from the diagram. So what will be the diameter of the circle? Diameter is always the 2 times of the radius. Diameter is equal to 2 times of the radius. Radius is given 2 meter. So the displacement will be 2 into 2, that is 4 meter. So you can see the difference between distance and displacement. In this diagram, you will get a clear idea what is the difference between distance and displacement, right? So you can see that displacement is most of the cases it is smaller than the distance, right? It is smaller than the displacement. Distance is always greater than the displacement, or displacement is smaller than distance, right? Now we will discuss speed and velocity, these two terms. Okay, so speed and velocity, as the definition we have already written, but let us find out with one or two example this speed and velocity. So speed and velocity, we will calculate one or two examples. Right. Now speed and velocity. So speed is in the previously we have written the definition. Speed is equal to distance upon time. Now the important thing is that everything should be in SI unit, or you have to convert it in meter. Generally the distance are given. Suppose the object covers from or travels from A to B 2 km. Now time is given in second. Let's say 2 km it covers in 30 seconds. Right? So what will be the speed of the vehicle? So kilometer per second is not a standard unit generally. Either kilometer per hour or the SI unit is meter per second. That is the SI unit, right? So that is very important while you will calculate speed and velocity. So you have to convert either meter per second, or you have to convert this time to hour. That is very important. So 2 km is generally 2000 meter. 30 seconds, keep it as 30 seconds. So what will be speed? In this case, speed will be distance is 2000 meter divided by time is 30 seconds. So time cancel. Now this is 200 by 3. So this will be 66.66. It will go on like this. Okay. So meter per second. What is the unit? Meter per second is the SI unit of your speed, right? And displacement will be same. Displacement formula is same also. Only the difference is we will take distance by time. In the previous examples also you can take, right? Distance by time. So distance is here 4 and displacement here is 2√2. So this is the difference, right? So when you will calculate velocity, instead of distance you will use displacement, and time same. Here also SI unit, if you will go, SI unit is also same as your speed. So SI unit will be meter per second. SI unit will be meter per second. Here also SI unit is speed is SI unit is meter per second. Right? So what we have learned in this video? We have learned that these concepts that already you know, but we just revised: distance, displacement, then speed and velocity, right? So in next part we will discuss about average speed, uniform motion, non-uniform motion, then instantaneous velocity, how we can calculate. Okay, then all the parts like velocity time graph, position time graph, we will discuss one by one, and gradually we will go to the equations of motion. Then we will discuss about calculus, and we will use calculus method to derive your equation motion, and by graphical method also we will derive the equation of motion. So by both the method we will derive equation of motion, and finally in this chapter the last concept is relative velocity. Then we will complete this chapter, right? So in this part 1 video, let's stop here. It was an introduction one. Now in the next video we will discuss some more concept. Thank you for watching the video. See you in another one.